in an effort for us to try and understand how much noise is in different variables, we ran test-retesting across all of the data set that we had. Test-retest is just a way of looking at data that kind of tells you if you measure something, the same thing, twice, what's the difference between the first and second time, or kind of technically a way of looking at the average difference in loads of different pairs of data across the whole data set. If you get a value of 1, it means there's a really strong relationship, as it were, or continuity between the data, so very little noise. If you get a value of 0, it's all noise and not worth looking at. So if we ran that across all the different variables, the sleep variables that we've got access to try and understand which are the most coherent, and this is the results we got.
Yeah, so as you can see here, so some relationships, you can see the HRV. This is going to have a higher test-retest, as you said. A test-retest of 1 basically means you're going to get the same every single time. There's no noise, there's no variance, whatnot. And then a 0 is just going to be you're basically sampling a blob.
And we'd expect HRV to be, ultimately it's a very individual character, which, as you said, my HRV when you measure it can be nearly 100. Some people's are much lower, some people's are much higher. And it's a measurement of your automatic nervous system tone, effectively, and so it's kind of a deep set physiological characteristic, and you'd expect that to be much more reliable, as it were, than REM sleep, which we think is very noisy, partly because of the measurement. Sleep stage measurement is tough, but also is going to vary massively from user from night to night.
Yeah, and if you think about the way that, for example, HRV is calculated, all you have to do from PPG is infer the heart rate, and then HRV is very deterministic from there. Something like, for example, measuring deep sleep throughout the night, there is very complex algorithms, and there's a lot more going on, a lot more noise can be introduced. So this is why it makes sense something like HRV is going to have a higher test-retest score, because it is just easier to measure.
And that has a big bearing going forwards, as because we've got big data sets with lots of data points, but we don't have the individuals' data. Effectively, we're kind of guessing all the time at the statistical confounding factors that also go into and affect a relationship. And so we're really looking for the percentage of variance one variable makes up in another. And so using variables that we've got confidence in that are measuring what they're saying they're measuring is important. So as we go on and talk about some of the other things we're doing, we're guided by what we're calling first order variables, where there's the minimum processing between the physiological data, which, as Cameron says, is the measurement of the PPG, and the actual outcome variable that we're using to test a relationship.
Yeah, so this is why we're not using sleep scores generated by wearables and whatnot, because we're kind of focused on the rawest signal. And I guess the next step with, for example, looking at noise test-retest is to compare this provider, this provider, this provider. How do they all measure up? How reliable are they, let's say, for HRV, for deep sleep and whatnot?
And that's something that Terra can do possibly uniquely, because it has so much data from so many different sources. So yeah, stay tuned. That's one for later.
Yeah, cool.